Today we want to talk about robotic simulation, and if you look around, it's actually not so easy to get a robot to learn how to grasp an object with reinforcement learning. So you see this a lot all over the news, but actually it's not so easy to really implement this. Especially the physics environments are very difficult sometimes to set up. It needs to be CUDA compatible, etc. But this can be all done. Still, a lot of algorithms are actually not very good at learning how to grasp an object, right? You see a lot of demonstrations which are usually just by imitating human behavior, but by really learning it, this is very rare. The only place where I actually found it to work was with DIPG, which is a package which is from Berkeley, which is already a couple of years old, but that's the only place where I really found it to actually work. If you have other places where you could set it up, then feel free to tell me. I'm always interested in this. So one problem is, right, what we see here is basically the GitHub repository for DIPG. It's based on some libraries, Mojoko reinforcement learning, Mojoko environments, and then the final hand DIPG, which really uses this algorithm to actually learn. The MJRL nowadays is actually replaced by RoboHive. So if you try to install this GitHub repository, you will run into a bunch of issues. I have run into these issues. I have rewritten some parts of the libraries so that it works even today on Ubuntu 24.04. Nevertheless, of course, it's very tedious if everybody else wants to do this. So what would be good if there's a solution for this where you don't have to always install robotic simulations in order to actually get it to work, control it, perhaps even do reinforcement learning therefore. And of course, this is a perfect invitation for this entire concept of SaaS, right? That you actually have this as a web service, that you actually have a cloud-based integration of robotic simulation and learning. And this is actually what I did. So that's what we want to talk about today. So if you click on my website, you can open this robotic simulation. So the idea is basically the following, right? We have basically made a front end and a back end. On the front end you have the website, and on the back end you have the Mojoko robotic simulation running. And you can basically already see the results, right? The resolution is currently a little bit low because the instances are expensive. So I'm looking to find something which is cheaper, so that also higher computing power can be rented cheaply. So what you can do on this demonstration is basically you can click at any point on the table. Your 2D click pixel position will be remapped into the 3D position on the table in the simulation. So basically this is transmitted from the front end, which I made in React, in White, in WebStorm environment, to the back end in the basically Python environment. Right? As said here, the arm has just grasped an object, and now we see, this is where we clicked before, there is the ball at the new position, and the arm is grasping the ball. So as said, a possible improvement for the future, of course, is to get a more expensive or more powerful instance, so that higher frame rate, higher resolution is possible. Just to get you an idea of the overview, right? So here's a little bit an introduction mathematically on what's actually done for reinforcement learning. So there's also, of course, the original paper of DIPG, which you can look at. For time reason, I'm not going to elaborate on this further for now.